You're lying in bed. The room is quiet. The lights are off. You've done everything right. No phone, no caffeine, early enough, and you're just lying there. Awake. Not anxious about anything specific. Not thinking about a problem you need to solve. Just awake, in the dark, alone, with your brain quietly refusing to cooperate. Here's what no one tells you about that moment. Your brain is not malfunctioning. It is not broken. It is running a very old piece of software that was written specifically for this situation, lying alone in the dark, and that software says, this is not safe. Someone needs to stay awake, and since there's no one else here, that someone is you. You don't have insomnia. You have a brain that was never designed to sleep alone in the first place. To understand why solitary sleep is one of the strangest things modern humans do, and why your brain keeps fighting it, we need to untangle 5 things. How ancient humans actually slept, and why solo sleep essentially didn't exist. The specific brain mechanism that treats being alone at night as a threat signal. What the data shows about solitary sleep and insomnia. Why your chronotype E, whether you're a night owl or an early bird, was never about personal preference, and what you can actually do with all of this. Let's go. Here's the number that reframes everything. In 2017, researchers from the University of Toronto and Duke University spent 20 days monitoring the sleep patterns of Hadza hunter-gatherers in Tanzania, one of the last populations on Earth living in a way that closely resembles how humans lived for most of our evolutionary history. Using actigraphy devices, they tracked when each person was asleep and when they were awake. Across the entire 20-day observation period, all members of the group were simultaneously asleep for a total of 18 minutes. 18 minutes? In 20 days. At any given point during the night, a median of 8 individuals were awake. The group was essentially never fully unconscious at the same time. Ancient humans didn't just happen to sleep near each other. They slept in a configuration that ensured the group was almost never fully vulnerable. Together. On purpose. So what exactly were they protecting against? The answer begins with a problem that every sleeping animal faces. Unconsciousness is dangerous. When you're asleep, you can't detect threats, you can't run, you can't defend yourself. Sleep is biologically non-negotiable. Every vertebrate animal does some version of it, but it comes at a cost. You're vulnerable in a way you're not at any other moment in your life. For most animals, this problem gets solved by choosing a safe location, a burrow, a treetop, a cave. For social animals, it gets solved by another mechanism, distributing the vulnerability across the group. Not everyone goes fully unconscious at the same time. The group, as a whole, stays partially alert even while individuals sleep. This is called the sentinel hypothesis, first formally proposed by Frederick Snyder in 1966. The idea is that in group-dwelling animals, individual variation in sleep timing, some sleeping earlier, some later, some waking in the middle of the night, functions as a natural rotation of watchfulness. The group stays covered even when any individual member is out. What the 2017 Hadza study proved for the first time in humans is that this isn't just theory. The variation in sleep timing across age groups, teenagers and young adults sleeping later, middle-aged adults sleeping earlier, older adults waking in the early morning isn't random. It's distributed coverage. The elders wake when the young adults are in their deepest sleep. The young adults stay awake past when the elders have gone down. The group, as a system, maintains near continuous wakefulness. Your grandfather wakes up at 4 a.m. and your teenager doesn't go to bed until 1 a.m. You've always thought of this as an annoying quirk of age. It's not. It's a sentinel rotation that your family has been running without knowing it. Somewhere back there, your 70-year-old relative who texts you at 5:30 a.m. is performing an ancient biological function that technically saved your ancestors' lives. This does not mean you have to reply. Now here's the crucial part. If the group is the safety system, if the whole point is that someone else is awake so you can go fully unconscious, then what happens to a brain that finds itself alone at night with no one to hand off to? Here's what your brain does when it decides the environment isn't safe enough to sleep in. It activates hyperarousal. Hyperarousal is the sleep researchers' term for a state of elevated physiological and cognitive activation that persists into the night. Racing thoughts, heightened sensitivity to sound, difficulty settling, repeated awakenings. It's your nervous system treating sleep onset as something that requires permission, and withholding that permission until it's satisfied that the environment is secure. Multiple lines of evidence now suggest that insomnia, not the occasional bad night, but the chronic inability to fall or stay asleep despite adequate opportunity, is, at its core, an adaptive response to perceived threat. Your brain isn't malfunctioning. It's doing exactly what it was built to do when it perceives that the conditions for safe sleep are not met. And one of the oldest, deepest conditions for safe sleep is, someone else is here. The data on solitary sleep and insomnia is consistent and accumulating, and it points in one direction. A 2023 population-based cohort study tracking 9,430 adults aged 50 and older found that social isolation was a significant predictor of new-onset insomnia symptoms over a 4-year follow-up period. Not prior sleep problems, not stress, not health status alone. Social isolation specifically predicted the development of insomnia in people who hadn't had it before. A 2024 study in sleep health found that loneliness, the felt sense of insufficient social connection, was significantly associated with insomnia, poor sleep efficiency, and nighttime awakenings. Not just correlated cross-sectionally, the pattern held across repeated daily measurements. And work from Matthew Walker's lab at UC Berkeley found that sleep deprivation drives social withdrawal. People who slept poorly were more likely to feel lonely, and loneliness in turn disrupted sleep. A loop. Bad sleep makes you more isolated. Feeling more isolated makes sleep worse. The mechanism is becoming clearer. Your brain has circuits dedicated to detecting social safety, whether the people around you are trustworthy, whether you are embedded in a group, whether the environment you're in is the kind of place where it's acceptable to go unconscious. When those circuits read low social density, no one nearby, no sounds of other breathing, no physical warmth, the threat detection system stays elevated. The nervous system runs a quiet background process asking, is it safe to let go? And in the absence of the signals it evolved to look for, it answers, not yet. This is an evolutionary mismatch, and it's one of the most intimate ones humans currently live inside. For essentially all of human history, sleeping alone was a signal that something had gone wrong. It meant you were separated from your group, exposed, without coverage. The brain learned to treat it as an emergency. Now it's the default condition for a significant portion of the adult population in industrialized countries. People living alone, sleeping alone, their brains running the same ancient alert that their ancestors ran only in genuine crisis. Your brain was not consulted when the single-occupancy apartment was invented. It has opinions. There is a wrinkle here worth naming honestly. The research on solitary sleep and insomnia is largely observational. It shows that social isolation and loneliness are associated with worse sleep, not that sleeping alone causes insomnia in everyone. Plenty of people sleep fine alone, particularly those who feel socially connected during waking hours, and those whose nervous systems have habituated to the modern environment. What the research does suggest is that for a meaningful number of people, the experience of nighttime hyperarousal, that restless, can't settle, wide awake in the dark state, may be connected to the absence of social signals the brain is designed to expect. The mismatch is real, even when the experience varies. Step back, and the sleepless night in the empty apartment looks completely different. You're not failing at sleep. You're not doing it wrong. And you're not uniquely broken. You are a social animal whose brain was calibrated across hundreds of thousands of years for a very specific sleep configuration, surrounded by people you trust, with coverage distributed across the group, unconsciousness shared rather than solitary. That's the baseline your nervous system was written for. What we've done, built a world where millions of people sleep alone in sealed apartments, with no sounds of another person's breathing, no physical proximity, no sentinel rotation, is create conditions that the human sleep system was never designed to handle. The insomnia epidemic isn't just stress or screens or caffeine. It's partly this. The most social of all the great apes, sleeping in an arrangement that would have registered for most of our history as a survival emergency. Your grandfather's 4 a.m. texts and your teenager's midnight restlessness are features. The single-occupancy bedroom is the bug. Here's the one thing. If you struggle to sleep, not every night, but often enough, try adding one social signal to your wind-down. Not social media, not texting. A social signal your nervous system can actually register. The sound of another person. A podcast or audiobook with a human voice that continues into sleep onset, not content you're actively following, just a voice. Research on background human vocalization and sleep suggests that familiar voices can reduce hyperarousal in the transition to sleep, particularly in lonely or socially isolated individuals. Your brain doesn't need someone physically present. It needs to register that the acoustic environment contains other humans. This isn't a cure for insomnia. It's a small patch for a massive mismatch, but it works with your biology instead of fighting it, giving your ancient sentinel system just enough signal to stand down and let you go. You were built to sleep in a group. Sometimes you can fool the system. And if the idea that being alone at night is enough to keep your brain on high alert, imagine what it does when it decides you've been cut off from the group entirely. Not just tonight, but permanently. Why ancient humans treated being cast out of the tribe as a death sentence, and why your brain still reacts to social rejection the way it reacts to physical pain, that one's next.